This is DC here. This is the second video on PN5180 NFC reader writer. In this video, I'm going to speak about the datasheet of PN5180. Now, this is the only document you can find about PN5180. You can get this from the internet, or you can go to the product page of NX website and download this document from there. This document, as you can see here, looks pretty new. It's the last updated 7th May 2018, and in this video I'm just going to go through kind of an overview of this datasheet. So I will be coming back to the datasheet in the later part of my videos as well, and you have to keep this document in handy, because this is the only document information you can find about this chip. So I would like to cover the following things in this video. First of all, this document is very comprehensive. This is too much for a software developer. So the document has got information for both programmers as well as the system designers. Besides normal programming, you'll also find information about the antenna tuning, antenna designing, and information about the voltages, all sort of capacitors. Probably that will be useful for PCB designers. I'm going to cover in detail about various registers and the EEPROM and every bit of the register. So here, most of the programming you'll be doing in this chip is about storing certain value in a register. Registers are the internal memory of a processor, and there are some fixed number of registers in the processor. So when I say processor, it is this PN5180, and each register has got a number starting from 0 and goes up to maybe 30 or 40, and the size of the registers is 32 bits. Now this document has got a very detailed information about what each of these registers does. It is just not the content of the register, it is the functionality of every bit of the register. You have to understand. It's too much for a software developer, as I mentioned before. And it has a feature called EEPROM. This EEPROM memory, which has got a firmware, which has got all the configuration data. And the interesting thing about the EEPROM memory is the configuration data is automatically loaded into the register during normal operation. We're going to see now a few bits and pieces about this as well. And every bit of the register does something or the other. So all information is present in the document. As I mentioned before, some of these informations are very much electronics. It speaks about say the signal timings, or it's very probably it's not a domain of a software developer. Probably it is more to do with the electronics or electrical engineering. So it has a firmware. If you have seen my videos on PN532 NFC chip, even PN532 also had a firmware, and here this firmware, as the documentation says, is upgradable, and the firmware implements all the low-level operations, so you don't have to worry about the signaling and the timing at this level. One thing this firmware lacks is the high-level protocol features. Say, for example, in case of a PN532 processor, the firmware has a command called enlist passive target. Now this command, when you call this command, it will look for a tag, and if it finds a tag, it activates and keeps the tag ready for further communication, like further reading and writing and so on. So such a feature is not available in this firmware. Probably as I mentioned before, the firmware is upgradable, you can find a new firmware from the NXP website. Maybe the later version of the firmware might provide a very high level protocol features. Until then, all these high level functionalities must be provided by the host, that is the Arduino, or if it's connected to the PC, it has to be done in the PC. So the firmware has got the firmware implements protocols like Type A, Type B, IS15693, and sorry, I was wrong here. It's if you want to implement the protocols like Type A, Type B, or IS15693 protocols, these are the very high level protocols. This has to be done in the host like Arduino or other microcontroller. Now in this video I'll be showing you some of the important sections in this document or a data sheet that will be useful to the programmers. So in the beginning of the document itself, you can find the features of this chip. So as you can see here, it supports Type A from the standard speed of 106 kilobits per second up to 848 bits per second. It supports the MIFI Classic. Now when we say about MIFI Classic, it means this has the feature to authenticate. Authenticating MIFI Classic uses a proprietary protocol called Crypto1. So that is present in this chip. So you can use a MIFI Classic card. So you can also use Type B, and you can use IS15693, and these are for the peer-to-peer type of protocol between two NFC devices. And this chip can also emulate as a card of Type A. Now the only interface that's available with the host is the SPI. Now this board suits very well for people who do the embedded programming with the Arduino, or it can be ESP8266, or it could be even with the Raspberry Pi. Any board that supports SPI interface can be used. And some of these are information about the standard pins used in SPI. So if you have done any SPI connections with Arduino, you've got a MOSI, MISO, NSS, SCK, and in addition to this standard signals, it has got what is called as a busy line, which is very well explained in this document. Some of the things like which I don't understand very well is something like this. There's a pull-up resistor. So I don't know what's the use of this pull-up resistor. Maybe it's I might have read about this maybe 30 years ago, but just at this stage, no, I don't understand these things now. So my advice would be, if you're a software developer, you try to read this document. Okay, it's very a lovely document to read, and if you come across some things like load balancing or loading or current or all those stuff, you can ignore. So you have to have a friend, okay, who understands these concepts. But I would say 50% of the document you can, as a software developer, you can understand, but remaining you can ignore it. So it's not going to affect your programming. If you go to page number 18, you see this IRQ pin, which is of very much useful for programming, and also the IRQ status register. So see the IRQ pin, you can connect this IRQ pin to one of the pin of your Arduino microcontroller. What this thing does is, there are so many events that are happening within the this chip. If it come across any exception or any event happening, all these events are channelized to a single pin. So, and the information about what event has occurred, what made the interrupt IRQ pin to signal, it's available in this IRQ register. This is this is a very good way of writing like asynchronous programming. So it's very easy to write a interrupt handler in Arduino. Either it's a falling edge or a trailing edge. So whenever you get an interrupt, there is an interrupt handler which is executed automatically, and you can immediately try to read this IRQ status, and you'll come to know what exactly is this interrupt for, whether it's a programming error or a parity error or CRC error. So this is something of interest. So this is very software, it's nothing to do with the hardware. Yeah. So further down in page number 19, this is the most important thing you have to understand. This is how the SPA communication has to be done. So the first step is you have to assert the NSS low. This is kind of a chip select. Then you perform the data transfer, whether you send the data to the chip or read the response from the chip. Then you wait for the busy line to go high, and after that you deassert or deactivate the NSS line. Then again wait for the busy line to go low. These 5 steps are so important. So I'm going to go through this we're going to see how this is implemented in Arduino in my next video. And in page number 21, you can see that this is the structure of the communication between the host and this chip. The first part is instruction, followed by all the parameters. Say if you're trying to write to a register, the first command is a write register, and the second command could be the register number, and the subsequent bytes probably will be the data. So this is the format you have to follow. And after we send this command to the chip will respond with this series of bytes, and all these bytes are the data. There is information about what is the maximum size of the instruction. It says it is 260 bytes. And also, after this command is processed, the documentation says the IRQ line can be checked to make sure there is no error, or you can find out what type of error, and also information about what the maximum response size you can have. You can have 508 bytes as a response, whereas 260 bytes in the command. Now, as I mentioned before, the command set of this processor are pretty straightforward and easy to understand. So if you have done any programming with the microprocessor, or it doesn't have to microprocessor. In fact, you can easily understand what it does. I mentioned before, most programming for this chip is done by either writing to the register or reading or writing to the EEPROM and sending data. So if you look at here, the instruction set are pretty straightforward. It has got, these are the instruction set. Got write register, and the command code is 00. It says write 132-bit value. It has got write register or OR mask. This is you can logically OR any 32-bit number with the register and write the result back to the register. This is the ANDing. You AND the value of it's a bitwise ANDing, the value of register with the value, and you got write multiple register. You can here this instruction writes only one register. If you want to modify more than one register, you can use this write register multiple. Obviously, now using this type of commands, you're going to do you're going to execute this instruction pretty fast. So you go read register, read multiple register. These names are very obvious. You can write to EEPROM as well. So anything you write to EEPROM stays there even without a power. You can read from register, read from EEPROM. Here you can write to the transmission buffer. So here, assume that you want to send some data to a RFID or NFC tag. You can first transfer all the data to this buffer. Then you can instruct it to transfer this data to NFC card. Send data, this is again does a multiple job. it writes all the data to the transmission buffer. It also immediately starts the transmission. So this will start sending the data to the card. You can read the response from the card. There's something called switch mode. Some of these, most of these instructions are very straightforward. Switch mode, this is a kind of simple, and there's so many things, so many modes, because this board or this chip can also do the energy harvesting. So you can the power it gets from the electromagnetic field of a phone can be used to switch an external relay or a switch. So something like that is possible. If you look at here, you got me for authenticate, and these commands in EPC inventory, these are all kind of related to the ISO or a type B tags, where you get the inventory of all the tags present, and you can activate one of them. So probably in my later videos I'm going to show you, how this thing works. And you got a load RF configuration. So here, see, the EEPROM has got the settings for predefined operations. For example, as I said, this chip is so comprehensive. Every bit of this the transmission, the protocol can be controlled, and it's a very tedious job if you have to remember everything. So when this board is made, so the EEPROM comes with some preloaded settings, so you can just in one single command you can load that settings and use the setting. For example, you can load a type A 106 kilobits per second setting, and you can start from that point onwards. So that's what the load RF configuration is. Probably you will be going through this in detail in my later part of my videos or in my future videos. So you can load, you can update, you can change the settings. So assume that you have got a different antenna and you want a different set of parameters, you can update the EEPROM, and from that point onwards the configuration is there for us to use. You can retrieve all the registers that are affected by the settings. Can be done used to some simple commands: radio frequency, RF on, RF off, and something to do with the test bus signal. Okay, so and following that, every instruction is explained, and these are the simplest thing. Anybody should be able to understand this. Look at how simple are these instructions. Write register. It says command code is 00. The parameters are the 1 byte which gives the address of the register, and 4 byte the value you want to write. That's it. There's no response. So this is a nice explanation on this. There are so many like that. If you keep scrolling, every command is explained in detail. There are also examples, and I'm going to explain this each of these commands in detail in my future videos as well. Now here you can see the list of predefined configurations, and assume for example you want to work with a type A tag, a standard MIFI tag, say MIFI Classic. MIFI Classic works with it's a ISO 1443 type A, the speed is 106, and see, this is the transmitter side and the receiver side. You can use this load RF configuration command, passing it 00 for the settings for the transmission side, and 80 for the receiving side. That's all. You don't have to worry about setting so many registers and so many bits in the registers. You don't have to know anything about that. So likewise, if you want to work with, say for example, a desk file in a MIFI desk file that works at a higher speed, probably you can just tell the system to load the 03 configuration and 83 configuration. Now these two are independent. You can have a 02 for transmission side, maybe you can have 80 for a receiving side. So these are the pre-built configuration setting. That you can use it. If you don't use these configurations, you will end up having entering the data into so many registers and so many bits, and unless you know what you're doing, it's very easy to get lost. So internally there is EEPROM of 255 bytes size. The EEPROM consists of so many information. In addition to the configuration which we saw before this, you can get information about the firmware version, the EEPROM version, the product version, the die identifier, and for each of this information you have to know the address and the length in bytes. And also the table tells you whether this data item can be modified or it just read only. And again, there's so many things here. Some of these things are pretty straightforward from the name, and some you have to talk to your friends and understand more. If you scroll further down to page number 61, you can see information about how to configure this for ISO type A type of tags and MIFA classic tags. These are the information you find when you read any type A or MIFA classic cards. One interesting thing I would like to point out here. If you look at these two lines here, what it says is the PN5180 connection to host is required. A host is required to manage the complete ISO type A and MIFA classic communication protocol. So this line, what it's trying to say is the firmware doesn't help you in doing the read and write operation. So there is no, say for example, if you compare this with the PN532, in PN532 there is a command to decrement the MIFA classic tags, or there is a command to write a block or read a block. Such commands are not present in this chip, in this firmware. You have to send the raw commands of the tag, so which it will be pretty easy once you know how to send a command. So one thing I can rest assure is once you get hang of this instructions, this chip is really interesting to work with. Now my advice is, if you are doing any project, a new project, and if you want to use, if you decided to use PN532, I would advise go with this one, PN5180. So this is a newer chip, and probably will understand more on how to do this RFID chip programming. If you scroll further down to page number 87, you can see the list of the registers in this chip. It is these registers you'll be reading and writing. So that's what the programming PN5180 means. And there are so many registers. Some of the registers are pretty straightforward. Some are very technical, go into the signal and timing level. So you have to pick up all the things you want to learn. Now I'll be discussing some of these which are required to do to read a tag or write to a tag. So for example, the first register, that's register 0, is called a system configuration register. Further down the document, it explains what is this register. Remember, every register is of 32-bit size, so you have to understand what each of these individual 32-bit does. The good thing is, in fact you'll be happy. Most of the registers have got so many bits that are RFUs, so that makes us happy. So probably half the register is like RFU. Don't have to worry about what it is. But even the rest, the remaining 50% of the bits are you might understand few or you might not. Okay, so you just have to be careful with that. Take one more example. This I mentioned before, the IRQ status. If there is a interrupt means whether an operation is successful, or it can also mean there is an error, or it can mean there's a CRC error, there's a parity error. So you can find out what the reason for the interrupt by reading the content of this IRQ register. And again, is very obvious. Now we have seen there is a command called read register. You just have to use the read register 04, pass this number 02. You will get a 32-bit value, and you have to decode what it is. Likewise, one of the simple registers IRQ clear. You can clear all the bits that are active here, and see, some of the things are pretty straightforward. IRQ enable, and you can decide assume there are around 22 events that can happen. You can decide which events you would like to channelize or pass through this IRQ pin. So you got a register called number 04, which controls your the trans receiver. It's all to do with the, say for example, whether to use a CRC, compute the parity, all those things explained here. And if you go further down, say for example this one. So this is register number 12. This is called CRC-RS configuration. This is a receiver. Okay, you can set whether to check the CRC in the response or not to check CRC. Again, it all depends on the command. Some response from the tag don't come with the CRC, some do come with the CRC. Again, there are different types of CRC, all those CRC polynomials, x to the power of say 12 plus x to the power 6 or so on things. You can decide what to use, and this is also pretty probably straightforward. Likewise, you also got like transmission configuration, So again, this you don't have to memorize, you just have to keep on understanding a little bit at a time. So you'll master this document eventually. So likewise, there are so many, probably there are up to 41, and remaining, these are all RFUs. So from this point on, every register is explained. Look at, there are 41 registers, and each register has got 32 bits. So in theory, you'll have to understand 41 times 32 bits, because every bit does something or the other. But as I mentioned before, look at that. The very first register, the system config register, the first 15 bits are RFUs. So happy here. So you don't have to. So you got only 17 bits to learn. And again, every bit, okay, as you can see, there some you can understand, depending on what you want to do. So there are so many things here. So I'll try to explain some of the things which are required, and it's very difficult to explain every bit, okay, like this. So like that, if you can see here, the IRQ enable register, again, some good information here. The first 15 bits are not used, so we're happy, and the remaining 17 bits where you can enable or disable those events. So like that, if you scroll down, you will end up reaching page number 112. That ends all this explanation of registers. Next comes, how do you upgrade the firmware in this chip? It's called a secure firmware upgrade. And there are, if you remember, in the very first video I showed you two boards. One is one of the cheapest board you can buy for like a 5 or 6 pounds. The other one is a proper one for NXP, the green board, which has got a processor and this PN5180 chip, and which comes with the software NXP. So I've not used that board myself, but I've read in the user guide of the chip, on the user guide of that product, you can upgrade the firmware. But if you want to do upgrade by yourself using this SPI, there is information here on how to do that, and it's a very good exercise. If you're a student doing your electronics engineering, probably can take this as a small project and try to upload the firmware onto this Chinese PN5180 NFC board. If you scroll down to page number 135, here you can see the table here. Now, earlier I mentioned that you can load the configuration. Now here, you got some details about what exactly this the load operation does. So if you load a configuration for ISO IEC 14443-106, these are all the registers that are affected, and these are all the values that are entered. So if you don't want to use the load operation or the load command, you have to manually load these registers with these values. Also keep in mind, the values that are loaded depends on the board, depends on the antenna, depends on so many factors the board is made. So unless you are a antenna or electronic designer, it will be very difficult to make out how to get these bits. And if you go to this, say for example, if you go further up the document, you can see what these 32 bits of this register is. You just have to convert this to the binary number and find out all those bits that are set and all those that are not set, and understand what exactly is happening there. So likewise, this explanation is given for every configuration you can load. And if you just keep scrolling there, you will come to the end of the document.